I have been given an interesting problem by one of my students to give the solution for this, and he said this is this is a problem he has difficulty with, and he wants me to give the solution. So I thought this is an interesting problem, and I thought I'll make a video out of it, so that many like him can view this video and clarify the confusion that they tend to have. Okay, this is the problem we have. So we are supposed to find out V1 and V2. Method is not being specified. So when you don't have the method specified, the choice is yours. You can find out V1 by and V2 with different methods. Okay, let us try to work out by different possible methods. Okay, I will try to first work out by nodal method. Let's try to explore the solution by node voltage analysis. Let us see how easy or how difficult it is going to be. The first method that we would explore is first method we will try to explore is by node voltage analysis. So I have made videos on node voltage analysis, so one can see those videos for better understanding or my style of handling things, okay, or approaching problems. So let's go ahead with this problem. So we will have node voltage analysis. I will take the diagram again, the circuit that is given. I'll copy this. All right, so I will paste it here. I'll reduce it in size slightly, arrange it properly, right? So when we are trying to do a problem by nodal analysis, we try to identify the junctions or the nodes in the circuit. So it's been given that V1 is one and V2 is another node, and we will try to form the one more node as the datum node. Let us try to have this as the reference node. So in nodal analysis, we identify the nodes and take one of the nodes as the reference nodes. Okay, now let's try to look at this network. If we look at this network, we have two current sources, independent sources, 2 amperes and 7 amperes, and there is a voltage source of 2 volt. An interesting thing to note here is there is a 10 ohm resistor connected across this 2 volt source. So this resistance doesn't have any contribution to do as far as this network is concerned. Why? Because when you connect a resistor across a voltage source, the magnitude of the voltage source, that is 2 volt, would be available across this 10 ohm. It is going to be this 2 volt potential difference is available across the two ends of 10 ohm resistance. So as far as 10 ohm resistance is concerned, there is going to be a 2 volt drop across this, and there is going to be current here. But for that, it doesn't have any role to play. It may have some power dissipated in it, but then it doesn't have any role to play as far as the dynamics of the circuit is concerned. So in the first step, we will try to remove this. This is a point worth noting. So the given circuit can be reduced into this structure. Okay, because this 10 ohm resistance doesn't have any role to play. So we have reduced it. Now my equations are simple. I can write down the node voltage equations, and then we can try to arrive at the solution. So we have two unknowns, we need to have two equations. How do we write the equations? We try to see the supernode here. The concept of supernode has to be understood. This entire thing is a supernode. I will try to mark the supernode. Let me try to mark it by a different color. Could be a color, this one. I will try to mark this area. I don't want that shape. Okay, this is my supernode. I'll try to extend it little. Okay, and maybe I'll try to take this. I'll try to write this V1 inside the circuit. I mean, this is my V1. Okay, V1 and V2. I've taken the supernode. I will take it little ahead like this. Maybe blow it little. Yeah, I think now this is better. Okay, that is my super node. Now with the super node, I'll write the KCL equation. So I'm trying to assume that the current is here is away from the node, here the current is away from the node. I'll try to write the equation encompassing this entire super node. So what is the equation I get? So at node 1, where the voltage is V1, I'll write the equation to be V1 divided by 2 is the current that leaves the node, and the super node comprises of V2 also. The current that leaves that node is V2 divided by 4. This should be equal to the currents entering the node, and there is 7 ampere also that is leaving the node 2 plus 7 equal to the current entering the node, that is ampere 2. So if you look at this network, this current V1 divided by 2 is leaving the node, V2 divided by 4 is also leaving the node, 7 ampere is also leaving the node, and 2 ampere is entering the node. So we form one equation. So we can write the simplified version of this equation. This comes out to be 0.5 V1 plus 0.25 V2 equal to 7 on that side will be minus 7 plus 2, that is minus 5. This is my one equation. I'll call this equation 1. Alright, now what is the second equation? You have two unknowns, you need to have the other equation. So we can formulate another equation using the relationship between V1 and V2. So V1 and V2 essentially are maintained at a potential difference of 2 volt. Okay, the difference in potential V1 minus V2 should be equal to 2 volt. So we have another equation, equation 2. Now we'll try to simplify equation 1 and equation 2. What I do is I will multiply equation 2 by 0.5, entire equation by 0.5, and subtract it from 1. Okay, so this I will do 2 into 0.5, then I will do 1 minus 2. 1 minus modified 2 rather. 1 minus the modified equation. Okay, so I'll do that. Okay, how will that equation be? So I will write the equation 1 as it is, 0.5 V1. I could have copied it. Anyway, it doesn't matter much. It's not a long expression. Minus 5. Equation 1. Equation 2, I'll multiply it with 0.5. I mean, you can use a calculator and simplify. Substitution method you can do. I'll just multiply like this so that I'll get this to be 0.5 V1 minus 0.5 V2 equal to 2 into 0.5 is 1. Alright, now what I do is I'll subtract one equation from the other. I have got two equations and two unknowns. You can do by any method. So what you will get is this gets cancelled off. I'll take a color, this gets cancelled off. I was trying to remove one of the variables, that's all. Now this is 0.75 V2 equal to minus 6. From this I will evaluate V2. I'll get V2 to be equal to minus 8 volt. Alright, that is the potential of V2. Now what is V1? So I'll substitute in equation 2. Okay, from equation 2 what is it we get? From 2 we get V1 equal to 2 plus V2. That is V1 equal to 2 minus 8, right? That is minus 6 volt. Okay, these are the potentials at V1 and V2. So our problem is completed. Like V2, rather V1 equal to minus 6 volt and V2 equal to minus 8 volt. Okay, so this completes the problem. As far as the problem is concerned, we are done with the problem. Is it okay? We need to check. Every time you do a problem, it's preferable we run a check whether our results are okay or not. So if I can substitute in these values in equation 2, do on the left hand side, do I get 2? So what will happen if I put it in equation 2? In equation 2, my V1 is minus 6, okay? My minus V2, so minus of minus 8. This is 2, which is your RHS. This is LHS of 2, right? So we can do the verification and we know that the answer obtained is correct. This is one method of doing it. We have done it by nodal method. Okay, let us try to explore the second method. The second method, I will try to do it with a different color possibly. I'll take this color. Okay, the second method we will adopt is by mesh current method. Mesh current, same problem, we will approach it by different method. Mesh current method. The objective is to give an idea of the various methods you can use to do network analysis. Okay, so mesh current method. So what I'll do is I'll pick up the network. I'll pick up the network. Alright, I'll copy, I'll paste it here. Reduce it in size, put it here. Okay, now how to write the mesh equations. How many meshes are seen? We have to know the potential differences in various branches to apply mesh equation. Again, I'll get rid of this. I could have copied the other diagram to be precise, but then let's try to have this. Okay, this is my V1. So we've got 3 meshes. All right, in the 3 meshes we have the currents, like 2 ampere current would circulate here in this mesh due to the current source that is present. Similarly, the 7 ampere current, I am following the direction of the current source. This is 7 ampere current is flowing here, 2 ampere current is flowing here. Let us try to assume one more clockwise current, I ampere in this. Alright, so we have found 3 meshes and we have written 3 mesh currents. So obviously when you have a current source in a particular mesh, that mesh current is equal to the current source, right? Value of the current source. So how do we now write the mesh equation? We will write a mesh equation for this mesh. For this mesh we will write, I'll start from top left corner, go in the clockwise direction, come back to the top left corner. Okay, so if I start, my drops are positive, so I'll take this to be 2 plus 2 volt is the drop. Okay, so I'm going here, positive to negative 2 volt, drop in potential 2. Then I'll go this way, top to bottom along 4 ohms. So I'm trying to take 4 into resistance, and top to bottom current obviously is I minus 7. I is flowing from top to bottom, 7 is flowing from bottom to top. So I minus 7 will go from top to bottom. Okay, then plus 2 into, what is the current from bottom to top? Or clockwise current is I minus 2. I minus 2 equal to 0. I have come back to the starting point. Okay, this is 2 plus 4i. Okay, so minus 28 plus 2i minus 4 equal to 0. Okay, this is 6i equal to, this is 32 minus 32, that is 30, I suppose is plus 30. Okay, so this comes out to be I equal to 5 ampere. Okay, I equal to 5 ampere. So what is the potential at V1? What is the potential at V1? How do we find out the potential at V1? So we need to know the drop that takes place in this 2 ohm resistor. Okay, so the 2 ohm resistor will have a drop of 2 minus I, V1 equal to, if I can write V1, the potential at V1 is 2 times the resistance times the current in the downward direction, that is 2 minus I. Okay, current in the downward direction from the node to the datum to the reference. Okay, so this is going to be 2 into 2 minus 5. This is minus 6 volt. Okay, so did we get the same thing? V1 is 6 volts, minus 6 volts. Similarly, what is V2? V2 again is 4 into the current in the downward direction, that is I minus 7. This is 4 into I is 5 minus 7. This is minus 8 volt. Okay, so V1 equal to minus 6 volt and V2 equal to minus 8 volt. Substituting in any one equation, you will get the same. You can verify whether the theorem is okay, whether the problem is okay or not. This is another method of doing it. Let us explore a third method. What is a third method we can think of as by superposition theorem? We have three sources, right? So we can even explore the possibility of superposition theorem. How the superposition theorem can be applied to this problem. How do we do? We will try to consider one source at a time, find the voltages and then superimpose them, right? It will involve 3 steps. So I'll try to copy the figure. I'll try to copy the figure. Perhaps this one I'll copy. This one I'll copy. Okay. I'll copy this figure. Okay. I'll paste it here. Okay, so we'll try to remove this supernode structure. I'll try to remove this current also. Try to remove this current also. Okay, so when we apply superposition theorem, what is it we do? We try to consider one source at a time and deactivate the other sources. All right, so I'll write my first step. Step number 1. What is the method? What is the source that we will have 2 ampere source on? Okay, only one source is kept on. The remaining sources are to be turned off. So what do we do for turning off of the source? I'll take the diagram again. Okay, I'll try to remove the unwanted stuff. This I'll remove. Now what do I have to do? I have to remove the other sources. What do we mean by removing the voltage source? We need to replace it by a short circuit. Remove all these things. Okay, I will have to replace it by a short circuit. All right. So the current sources are to be opened. Okay, so the other current source is removed. I have created an open circuit here. Okay, so I'll remove this part also. Let's not bother too much about the nodal analysis, right? So this is how the circuit becomes. If you can see this circuit, it is simply this 2 ohm and this 4 ohm, they are in parallel to a 2 ampere current source. So there is going to be a current division between the 2 branches because these 2 branches are, they're coming in parallel with 2 ampere source. So what is the current here? What is the current here? Okay, so I will call this as I2 ohms dash. Okay, this current is equal to, total current is 2, the resistance of the branch is 4 divided by the sum of the 2. That is 2 into 4 divided by 6. This is 8 by 6 ampere. Alright, so that is going to be the value of, 1 second, I'll just take the help of my calculator so that I can put the values. Okay, this is 8 by 6, right? Let's do it. This is 1.33 amperes. Okay, so this is I 2 ohm dash. This is I 4 ohm dash. So what is this I through 4 ohm dash? It is 2 ampere is the current entering the combination. Resistance of the other branch is 2 and the total resistance of the parallel combination is 6. Or we could have simply we could have done it as 2 minus 1.33. That is also okay. So this comes out to be 0.67 ampere. All right. So the total current is 2. A part of the current is 1.33 is flowing through 2 ohm and 0.67 ampere of current is flowing through 4 ohm. So we have done due to one source. Okay. So now next is we will try to consider the other source. Again, I'll take the same diagram. I'll take the same figure. I'll copy the figure. I'll put it here. I'll paste it. Now this is my step 2. I'll write my step 2 now. What is my step 2? I'll take the other source now on. Which one? Let's pick 7 ampere source on. The remaining sources are to be turned off. Turning off means the current source has to be opened up. So I will open the current source. Alright. And the voltage source has also to be switched off. So switching off condition of a voltage source is replaced by a short, and that of a current source is replaced by an open circuit. That is what we have done. Okay. So now how is the current distribution? The current distribution has to be given a different name now. Alright. So the name that is to be given is the direction of flow of current is now this way. Because we have only one current source, we can actually find out the current direction. If there were multiple sources, then we may have to assume arbitrary current, then we may have to evaluate. If we get the positive sign, then we infer that the current assumed is correct. If it is of negative sign, then we conclude that the assumed direction of flow of current was incorrect. It is opposite to that of what exactly is flowing. Now again, current division, 4 ohm and 2 ohm, they are coming in parallel with 7 amperes. We will do current division. Now for convenience, now the current that is going through 4 ohm, we will call it by double dash. This is I through 2 ohms, again by double dash. And what we do is, in every case, we will try to have one notation. Like, what I mean to say is, this current is flowing. I'll not mark it here. I'll mark it here. The direction of current I'll mark. Okay. Now, the second step, during the second source, what is the current now? I 2 ohm double dash, okay, is equal to, again current division, it is 7 into 4 divided by 6. I suppose you know how to do it. Okay. So when two resistors are connected in parallel, we apply the current division as the total current entering the junction multiplied with the resistance or other branch divided by the sum of the resistances to find out the current in any one branch. Okay, if I am interested in knowing the current through 4 ohm, I will take, if I am interested in finding out the current through 2 ohm, that is 2 ohm in this branch, I will take the total current multiplied with the resistance of the other branch. Okay, that is 4 ohm divided by the sum of the two, 4 plus 2, 6. Okay, this comes out to be equal to 7 into 4 divided by 6. That will be 4.67 ampere. Alright, so this is one current. The other current is now simply we can find out I through 4 ohm is equal to, it is simply 7 minus 4.67. This way also you can do. This will come out to be minus 2.33 amperes. What is the direction of flow of current? We'll try to use the same yellow color. Here now the current is upward current. This is also an upward current. Okay. Alright. So we are able to find out the current contribution in these two resistors due to 7 ampere current source. Okay. So we have one more source to deal with. Step 3 would be we have one more source, right? So what is that source? It's a 2 volt source. 2 volt source alone is on. Source is on. The remaining two sources are kept off. Okay. So I will try to take the circuit. copy, paste it here. Now I have to remove the current sources, right? I have to deactivate the current sources. How do I deactivate the current sources? I'll replace them by open circuit. So I'll open this. I'll open this also. I opened the current sources. Now how is the current distribution? I'll remove this also for the time being. I'll remove other. I'll remove the we are supposed to calculate the voltages, right? Okay, we'll find out the currents together and then find out the voltage. It hardly matters. Okay. Now how do we find out the current? Now the current that is going to flow in these branches, it's like this and it's like this. Same current flows from the source of 2 volt. The current flow would be from positive to negative. The current flows in the anti-clockwise direction. Okay, so in this branch it is like this, in this branch it is like this. So we will now designate the current to be I2 triple dash and this is I4 triple dash. Okay, both are same. Okay, so I2 triple dash equal to I4 triple dash. We'll split it and write. Okay, because we need to write the polarity. I2 triple dash is nothing but the current through 2 ohm resistor due to the 2 volt source. This is equal to 2 divided by 6. Okay, 2 volt source and total resistance is 6. This is 1/3. This is 0.33. And what is the direction of flow of current? It's evident. It is from top to bottom in 2 ohm. Alright, now what about the other current? I4 triple dash is also 0.33, but the direction of flow of current is opposite. It's like this. Alright, so now we are able to find out the current in the two resistors contributed by each source independently. What I am trying to do is I am trying to evaluate the current through 2 ohm, current through 4 ohm when all the 3 sources are present simultaneously. Then I will take out the current multiplied by the resistance to get the voltage. We could have independently calculated voltages and then we could have added up. That also we could have done. Or we are calculating the currents, then combine the currents, then get the voltage. Alright. So now we will take back the figure. I'll take back my figure. This one. I'll copy this and paste it here. Now I'll superimpose. Okay, so what do we mean by superimposition now? By superposition theorem, by superposition theorem, my I through 2 ohm, what I mean is, this is my I through 2 ohm. I'll not put the direction as of now. I'll try to see what is the direction of flow of current. This is I through 2 ohm. This is I through 4 ohm. Okay. How do I compute that? 2 ohm resistor, right? In 2 ohm resistor, I'll try to take the upward current. Let us try to calculate. Okay. I through 2 ohm. Okay. Simply I'll take 1 by 1. Okay. I'll try to take I3 2 ohm in the first case. It is 1.33. Okay. What I mean is this is I2 dash plus I2 double dash plus I2 triple dash. That's what I mean. Okay. So I2 dash. What is I2 dash? I2 dash is a downward current 1.33. Okay. This is downward current 1.33. Okay. I2 double dash. I2 double dash is 4.67 in the upward direction. So I will take this to be minus. This is 4.67. Okay. Downward current I am taking positive. Okay. And this is 0.33 plus 0.33. Okay. If I do this, 0.33 has to be positive. Okay, so this comes out to be approximately 0.67. This is 1.66. How much is this equal to? 1.33 plus 0.33 is 1.66. 1.66 minus 4.67. This is 3 point minus 3 point. How much is that? 0.33. 66. 1 second. Let me do again. 1.33 minus 4.67 plus 0.33. This is 3.01. Or if I have the decimal properly adjusted, I could have got it to be 3 itself. Okay, minus 3 amperes. This is my I through 2 ohms. Okay, so now what is V1 now? So V1 is 2 times the current through it, that is I through 2 ohms. Okay, so this is equal to 2 into 3.01, that is minus 6 volt. Okay, so this is what we had got earlier. And what about the other current? I through 4 ohm. How do we do? I through 4 ohm is again I4 dash, that is the current in 4 ohm resistance due to the first source of 2 ampere, then I4 double dash, that is current through 4 ohm resistor due to 7 ampere current source, plus I4 triple dash, which is the current contribution in 4 ohm resistance due to 2 volt source. I will have to club all the three. Okay, what is I4? I4 is 2.33 upward current. So I'm taking upward current to be negative, right? I can do it anyway. I'm taking upward current to be negative, so let me take it that way. So I'll call this minus 2.33. Okay, upward current is negative. Okay, so next is it is 0.67. Okay, first is 0.67. I can take it in any order, it hardly matters. Anyway, 0.67. Okay, that is downward current, right? So I4 dash, I'm picking up this current, this value. I4 dash, then I4 double dash, this is minus 2.33. This is minus 2.33. And then the other current, this again is minus 0.33. Okay, this comes out to be minus 2, right? I think this is minus 2. 2.01 or 2.01 ampere or 2 itself. Okay, now what is V2 equal to? V2 equal to 4 into this current I through 4 ohm, that is minus 8 volt. So my V1 is minus 6 volt and V2 is minus 8 volt. Alright. Okay, this is how we do. Method is yours, the choice is yours, how you want to do the problem. The third method that we have adopted is a superposition method, wherein it is the tedious. You have to take one source at a time. Tedious in the sense it is elaborate. Otherwise, there is simplicity. The chances of you making the mistake is very, very less if you apply superposition theorem. Otherwise, if you can understand nodal method or mesh current method, this comes out to be very easy. It is not at all a difficult problem. But all you have to do is you have to understand the nature of circuit. Like whenever you have a resistance across a voltage source, you might as well simply remove that resistance. It doesn't matter. The resistance doesn't matter at all. Only thing is that this resistance will there'll be 2 volts across this 10 ohm. That's all. Beyond that, this 10 ohm doesn't have any role to play as far as the other part of the circuit is concerned. So you can remove this. Similarly, a point worth noting is if you have a series resistance in series with a current source. You have a current source. Let us say there is a resistance. What this resistance has got to do as far as this current is concerned? It doesn't have any role to play. This current will pump in I amperes of current irrespective of the magnitude of resistance. So all you can do is here in order to give path for the current to flow, you may have to replace it by a short circuit. So this R you can remove the R, but then you have to replace it by a short. So you have to remember these points carefully. If you have a resistance across a voltage source, you might as well remove that resistance, replace it by an open. That is what we did in this problem. Similarly, if there is a resistance in series with the current source, you remove that resistance and replace it by a short circuit. Okay, and I suppose the problem is evident and clear. So in all the methods, we are able to get V1 to be 6 volts and V2 to be minus 6 and minus 8 respectively. V1 and V2 are minus 6 and minus 8 volt respectively. So you can adopt any method and you can solve. This was a problem posed by one of my students. He said, "Madam, you please help me with this." So I thought I'll make a video of the problem so that people who are learning or people who are watching my videos, they can learn from this. Thank you. I'll try to look for a problem with dependent source, a similar problem with dependent source. Okay, this is with independent source. How to deal a problem of this nature if a dependent source is present. I'll try to take it up in my next video. Thanks for watching. If you have any problems of any nature, please do give it to me.